The first presentation that we have today is on the cloud radio OpenEdge server design. And so for those of you, how many people are familiar with the OpenEdge chassis? That's basically the nucleus of our Edge project or sub-project under the telco group. So what we've done in the Edge is it was focused around this one product concept, an idea of how you could take the goodness of the OCP Open Rack and the tenets embodied in that, have openness, efficiency, those kinds of things, and how would you collapse that into a smaller device that could be deployed at the far edge. And so that is a chassis. We've got some pictures that I can show you a little later in the presentation to give you some idea of what the chassis looks like. Obviously there's several implementations of it in the Expo, and currently we have between lose track, it's either 5 or 6 now solution providers that will provide chassis and sleds. And so in this case, Nokia has a sled, a 1U. So this is a 19-inch rack mount chassis. It's either 3U or 2U in height, and it's kind of split in the middle, and you have half U or half width servers that slot into these that we call sleds. And so there are many different types of sleds there, and there's different types of CPU types that are on those. In Nokia's case, we have an Intel SP processor. There's others that have Intel D processors, other Xeon SP processors. We have a specification for an ARM processor board from Ampere that's not been, hasn't gone through the whole specification yet, but you can actually look at the draft on it. We make available a Ethernet switch that can go into one of those slots, and we have work that's been done on a battery backup unit that can also plug into one of the slots and provide a battery backup for these. The OpenEdge also has in the lower corner 2 power supplies and a rack management controller that provides Ethernet, an Ethernet switch, and that goes to all of the server ports so that you can actually plug in one Ethernet cable and then be able to get to BMCs of each of the different devices that are in the chassis without having to run a separate management Ethernet. All cables are on the front. The rear has a power bus that's implemented. This DC 12-volt DC bus, kind of like the Open Rack version 2, is implemented though as the back plane, and there's a power insertion board and then the sheet metal, and that are all OCP accepted products, which means there's a full design package for this. So if you have the equipment to build one, you can build one. You can build it and make it available to others. Obviously, it's what we'd like, because the ecosystem wanted to be as healthy as possible with many different choices for those people who'd like to deploy this solution. So in Nokia's case, we did in 2017, 2018, a 1U server, and this talk and presentation is about an upgrade to that. So this is the 2nd generation of our 1U server, and we'll go into some of the details on that. And actually, see, while we're still here, for those who aren't aware, the President of the United States tried really hard to help us out for the summit. For those of you who aren't familiar, there was a travel ban that's been in place where the President, in conjunction with the CDC and the Homeland Security, had a ban on travel from certain countries. The presenters for this presentation were actually affected by that. It was lifted on the 8th, and it wasn't enough time for the logistics to work out to actually get them here. And so what we're going to do is we're going to have a hybrid presentation. So I'm going to do some of the talking, and then I have Those guys are going to present the technical meat of the slides, and then we'll come back and we'll talk about the next details, and we'll take questions and stuff. And actually, as an added bonus, I do have the author of the specification on a Teams meeting, and we'll be able to take questions, and he can answer questions if you have them. And also on the virtual, they're both, both the presenters are online in the virtual meeting, so if you have questions, you can do that. I'm not sure how many folks in the room are also following along in the virtual, but for the folks that are only virtual, they can ask their questions in that chat, and we'll channel those back through to you guys in the room if we get questions from there. So in any case, so this presentation, we're going to have Tommy from Nokia and Raymond from ASUS, which is a joint presentation and a joint submission from those two organizations. Like I said, this is going to be an update from a previous specification. And so the specifications, you can go read this new specification, and it's really meant to, each specification is kind of a standalone, so it's not just a BIS to a previous specification that's very terse. It's actually, a lot of verbiage that's covered. It can kind of stand alone, even though it is an update to an existing specification. This product has been presented to the group. We had comments. It then passed the comments, went to the IC. The IC has accepted this, and Nokia as a solution provider is providing this in the marketplace, and it's an OCP-inspired product. So now I'll let Tommy take over.
Hello, my name is Tommy
from this point.
From Nokia Data Center Solutions, and I will talk a little bit about the background that led to the development of our second generation OpenEdge server, and about the technology enhancements that helped us get there. This picture is showing different types of data centers, ranging from far edge data centers to central data centers. On the right side, you can see centralized data centers. They are large in size, few in numbers, far away from the user, and they can very efficiently handle different kinds of non-real-time workloads. On the left, there are far edge data centers. They are small in size, large in numbers, and being close to the end user, they are optimally located for processing mission-critical, delay-sensitive workloads. In the far edge data centers, the servers can be located at the cell sites, right next to the antenna, so closest to the end user as possible, minimizing any transmit delays. Running timing critical applications in a far edge data center requires the server to have high performance and high efficiency. For Nokia, as a telecom equipment provider, running cloud-based telco applications is one of the key use cases in the network edge. For example, vRAN workloads are very compute intensive. The higher the processing capacity of the CPU, the more dense and the lower the cost of the solution can be. As 5G is increasing data rates, the networking functions must scale up respectively, which often demands for 100 gigabits per second interfaces in a server. Certain vRAN workloads are more efficiently processed using a hardware accelerator. Support for high bandwidth networking and hardware acceleration require the server to provide the needed expansion slots, power feed, and cooling. Other edge cloud use cases include multi-access edge computing, radio intelligent controller, a part of O-RAN, IoT, cloud gaming, or the enterprise solutions. These perform functions like video transcoding, artificial intelligence, and machine learning, which can also benefit from the use of general purpose GPUs. So this page summarizes the technology enhancements that we have taken into use in the latest generation of OpenEdge server Sled compared to the previous generation. So first of all, the Intel Xeon processor family is now of generation 3, so Ice Lake, bringing a significant increase in the core count. And also there are some platform improvements like new instructions to better cope with real-time processing needs. The amount of memory buses is increasing from 6 to 8, and at the same time the memory bus speed is increasing up to 3200 mega transfers per second. The PCIe buses are now of generation 4, so effectively doubling the speed of the lane or the bus, and at the same time also the count of PCI lanes is increasing from 48 to 64. And another big improvement is that we are now supporting the OCP version 3.0 module, which is hot swappable compared to the OCP version 2, which is a mezzanine. And the version 3 also has higher TDP and therefore performance, allowing several options to be developed on that platform. And one significant improvement is that in the OCP v3 we are able to fit 2 QSFP connectors side by side in the front panel, so that enables dual 100 gigabits per second Ethernet cards, for example. The Sled thermal performance has been increased, so we are now able to cool a Sled up to 500 watts, and this is to support the increasing TDPs of the CPUs, but also to support any higher power accelerators or NIC cards. And in the storage, we are moving from 2.5-inch SSDs to EDSFF E1Ss, which are more compact and can provide a more dense solution. And they also support cooling much better by using different heights of heat sinks. And then for the environmental and regulatory compliance, having done all of these enhancements, we are fully compliant with the OpenEdge specifications, including full NEPS level 3, which includes EMC safety, Zone 4, acoustics, and so on. And we are also, of course, still compliant with the extended operating temperature range that has been set for OpenEdge servers and other devices.
We'll hear from the from our other part of this. Let's see.
Hi everyone, my name is Raymond Huang. I'm from ASUS ESB, Enterprise Solution Business. Today I would like to talk about OpenEdge server Sled in the 1U half-width design that we are contributing to the OCP Foundation. Here are some of the highlights and key specifications. The server is based on the single socket design using Intel 3rd generation Xeon Scalable processor, Ice Lake. It supports up to 230 watt TDP, with the total power feed up to 500 watt in each server Sled. On board wise, we have the Intel 6621A for the PCH. We also implement SB2600 for the BMC to improve the overall performance and the security feature. On the PCIe expansion wise, we have one PCIe slot and one OCP mezzanine slot. Both are Gen 4 by 16 support ready. On the PCIe slot, we support single deck GPU card or FPGA card or a standard PCI add-on card. OCP 3.0 mezzanine card, you also support up to 200 gig. On the storage wise, we have two of the E1.S in the front. This is the NVMe drive. We implement this for high performance density in such a space constrained server design and cooling consideration. There are total two of the M.2 on board you can use as the boot drive and 1+1 mirroring. Overall, on this particular server sled, there are two flexible options on the fan module you can choose from. One is the front to rear airflow and one is the rear to front airflow at your choice. On the right hand drawing on the E1.S drive bay, this is hot swappable and also toolless design. This is the front and rear view of the server sled. Indicate there's total two E1.S in the number 8 location and where the PCIe slot located in the number 7 location and the OCP mezzanine slot on the bottom right, number 6 location. You also see the fan module that were implemented along with the number 2, which is where the backplane power connector, and number 3 is the backplane signal connector located.
So now, just to round out, as we were talking earlier about the OpenEdge system as a whole. So on the upper left is the chassis itself. It can accommodate both 1U or 2U servers. In this particular discussion, we were only talking about a 1U server. There is a 2U server that can go in that we'll have a different specification presentation on. The main thing for it is it can use a full length double high PCIe slot so that you can have a maximum sized accelerator function in there, whether it's GPU or other type accelerators. So then there's the one in the middle there shows like kind of a fully dressed out chassis with 5 servers. And if you can also see on the in the chassis view on the left, the one slot on the far left lower where there's the 2 slots for the power supplies. Power supplies can come in 3-phase, single phase, DC, neg 48, depending on the power supply, and that converts it to a 12-volt bus. So what you can't see in this particular view of the chassis is there's a power distribution board that takes the input from the power units and then distributes that up to a backplane riser that has those DC bus bar that the server sleds plug into that Raymond spoke of when he showed the connectors in the rear. So those 2 connectors in the rear, one is signal and one is power, and it has a guide pin for alignment. And that's a standardized interface on the OpenEdge. All sleds have that in common. The signals actually go down to what would be in the middle of the, kind of in the middle or like the right hand most of the 3 pieces on the left there is the rack management controller. And in addition, it has a BMC built on that provides telemetry information and control of the power supplies, but it also has an Ethernet chip built into it so that it can provide over that signal connector the 1 gigabit Ethernet to each of the sleds. So then, there's some links to the products and links to the marketplace if you guys are interested. And then, the other things is standard items for all of the work group items. We have regular project calls. You can get to that through the OCP main website, clicking on the project group, there's a link there to take you quickly to the calls. And there's also a calendar so that you can see at a glance what projects are having meetings at what time, and then it obviously has a click-through link for you. We'd love to have you join the OCP OpenEdge working group mail list, and there's we usually have anywhere from 10 to 20 people on the call, but on the mail list there's anywhere 500 to 600 participants. So there's if you really want good information on topics, go to the mail list. If you for high bandwidth communications, we'll go for the project calls, and then obviously twice a year we'll have a summit where the engineering workshop, so we can have the very high bandwidth type of communications with each other. All right, so thank you. Do we have any questions or any comments? And like I said, I have Tommy. Can you hear me?
Hi, Greg. Yes, I can.
Yes, okay. So Tommy's online, so I'm not sure if he can hear you, but I'll repeat the questions for you.
What is the maximum data rate of connections that those servers are designed for?
Okay, did you hear that, Tommy? The question
maximum data rate. Could you repeat that?
Yeah, I think I've heard you mention 200 gigabit ports on the servers. Is that correct?
Okay, he's asking what's the maximum throughput available on the system, and so I'll tell you, let me help him out. So there's an OCP version 3 mezzanine slot, and that slot has enough real estate now so that we can get 2 QSFP format connectors on there, right? So basically, that gives you 2 100 gig interfaces today is the current Ethernet cards that are available for that slot, and those are commodity parts, right? So you can get them from Intel, an Intel variety. You can get them in a Mellanox variety today, and then additionally there is a PCIe card so that you could plug in an additional, say, 2 Ethernets there as well. So you get a total of 400. But there's more PCIe bandwidth because it's of the latest generation, so there's a lot of throughput available there.
Thank you.
Okay. Thank you, Tommy. Sorry, go ahead.
Question on the system management, what you said, like about
The RMC?
RMC.
Okay.
Has there been any collaboration with the DC SCM side on the server data center module on the edge space, so that one common system management solution could be used?
Yeah, so the question is, we have their DCM space, or have we collaborated with them on the RMC? And actually, we predate that effort. And so there was close collaboration because they wanted to use some of the features that we had used in this Edge product. This was one of the, by basically taking the management control for the power supply, and then on that board adding the Ethernet so that you can have both the 10 gig uplink from that uplink and downlink. So there's 2 10 gig ports, and then there's a RJ45 1 gig connection that comes into that switch. So then through that out-of-band management network, you're able to get to the BMC to do the telemetry of the power supply and the chassis, but then also speak to each of the servers. And all of those have Redfish interfaces so that all of the communication can be over Redfish and uses the standard profiles that we have. There's a telco profile that we support. We also support the server profile for the servers, or the server sleds.
Thank you.
Okay, no worries. So are there any other questions? Comments?
Hi, Greg.
Yes.
Is the intent of this design to be able to use multi-vendor sleds in the same chassis? Or
Absolutely.
It is. Okay.
Absolutely. So, so I'm sorry. Let me put this one back up. Okay. So the reason. So we've got a couple different OCP logos here, right? So you've got one is OCP accepted, and the other is the inspired. Okay. And then the solution provider. But so what the OCP accepted mark means is that that product and that solution is available with a full design specification. So there's a BOM, there's a step file, everything necessary for you to create a duplicate of that. And we've actually, in the early days of the project, we actually collaborated and sent samples to each of the vendors that were interested in producing these, actually swapped units to make sure that we were interoperable and that our specification was sufficient to be interoperable. So yeah, so the whole concept is, you can get power supplies from different vendors, the RMC from different vendors, the sleds from different vendors, and on the back of the sled, when Raymond was describing the sled, on the back side of that sled, there are those two connectors, one for power, one for signal, right. Along with several of the other, the width and the height, but then actually the thumb connection that holds the servers into the chassis, all of that's specified. And so from our point of view, for the software folks, you say, oh, that's an interface. And so what we've tried to do is to define the interface, but it's a physical interface in this case, so that we can ensure they're interoperable. But
okay.
yeah, and also, that's what I was saying too, you're not limited in a server type. So our server is inspired because there's not the full design package for it. So the different manufacturers have created their own server. A lot of them are very similar. Some use different CPUs for different use cases. You want a little bit lower power, that kind of thing. And so for, maybe they had a use case someone came to them for and they developed a server sled for it. But they're interoperable so that you could, start with a chassis from one person, decide, oh, this guy's got a server that I like, put it in. Oh, you could get an Ethernet from this guy. We're still looking for a storage card. What we really like to have is a sled that has a lot of storage, so you could consider you're making a CDN box or something, right? So you have a lot of storage, and you could have the compute capabilities there. And again, all of this is made for the far edge. So, one of the things that as the telco group in general and the Edge project in specific, at first we were focused on the far edge, and that was the initial thrust of that sub-project. But since we've done that, and it had a very kind of narrowly defined use case, which was, the wireless cell sites for 5G essentially. And especially the virtualized 5G, not the discrete components that we have today, or So when you disaggregate, your 5G, this is the device that would do that, and it has the right form factor, and it fits into the same footprint that's used by the traditional radios. So where you have like an outdoor enclosure that's at the cell site or on the tower or at the top of the roof, whatever, you can actually come in and take out your existing radio and then put this in, and you're ready for virtualized cell sites at that point, right? And so that's kind of one of the formats. So now we're going, okay, there's a big interest in Edge. And so as the Edge group, we're now looking for, well, what's the next version of an Edge device? What does it look like? Is it 19-inch rack? Can it be a little bit deeper? Is it something, we've had presentations from folks in transportation for like a side of the rail application. We've had some shipborne applications. And so retail, industrial IoT, their requirements aren't quite as strict as telco requirement for their 5G site deployments. So we can relax some of those rules and come up with the different form factors. And so that's something that we're hoping to get some submissions and some specifications around those new form factors and what that would look like. But rest assured with OCP, right, what we're trying to do is to drive volume, because volume keeps the cost low. And so that's kind of what we're, not only the cost is important, but also the scale, the efficiency, the ability to scale it, to use things at scale rather than, this works great, but it takes a lot of time to service, keep your costs low. All those things you've heard of OCP from the keynotes of the goodness of OCP, that's what we're trying to accomplish. The telco was then trying to meet telco goals with the OCP gear that's coming out of the other project groups in there originally. And now we've actually started focusing on specific products that really are telco niche products, but now wanting to move a little bit further into the edge, because that's kind of where the expertise right now for that edge product group is.
Great, thank you.
Okay.
One more question.
Yes.
So, in terms of NEBs, how is the spec going into details about how these chassis are designed for NEBs compliance versus the traditional 19-inch OCP racks or 21-inch racks?
Yes. So, okay. So the question was like, do the specs have how NEBs is achieved, I guess, would be the kind of the question, right? And so the NEBs requirements like that Tommy had listed, right, were the target NEBs. So we're in the OCP, we tried really hard to kind of tease out what NEBs was important and what was, we've always done that. And so we've taken those things that are very important, and those have become incorporated into the original specification. And the expectation is that you can take that product, and as a solution provider, you could take it and then have it tested. And so when we say it's NEBS compliant, or when Tommy says it's NEBS compliant, what he means is that the solution provider has taken that and had it tested and has achieved NEBS certification. So the specification is sufficient to achieve certification, but it's up to the, it's not like just because you make that product, you don't just inherit NEBs. You actually have to take your implementation, take it to the test site, and have it tested and then certified. And that goes all the way not only from the chassis, but to the racks as well. So like things like the Zone 4 seismic, for instance, is usually not just the chassis. When we speak of Zone 4 seismic, that's actually a rack full of the chassis that was put on a shaker plate and actually passed the Zone 4 seismic requirements in order to achieve that specification. The same with some of the temperature things is just a simple, the device, and some of the destruction testing. Luckily, we don't have to test, destroy whole racks, but, depending on which NEBS requirement it is, it does have to be certified, and we can't guarantee that anybody, who makes it is going to be NEBS certified. It has to be a case-by-case basis. But you're in the marketplace, right? That solution provider who's providing that gear should be able to answer those questions for you. And obviously, if it's important to you, then you can say, hey, well, I'd love to do business with you, but we require some NEB certification. And yeah.
Follow up with one more question.
Sure.
Based on what you commented on the different form factors, etc. I see this particular thing is going after the full depth chassis. I've seen in the telco edge space various implementations with 17-inch depth chassis, are like even short depth being prevalent.
Yeah.
Is the spec addressing any of those specific use cases?
Well, yeah. So OpenEdge is actually. You really can't get there, and there wasn't any dimensions, but it's a 420 millimeter deep server, and then it's a 19-inch rack. So, I forget that aperture if it's 430 or 440. I'm sorry. I work in inches, but I do remember, the 420 is the millimeter of the depth. We always talk about that in terms of.
420 is around 17 inches.
Yeah. So you can go in. This would be useful for like a 600 millimeter rack. So you don't have to have the 1,000 millimeter or the 1,500 or 2,000 that it requires for some of those larger servers, right? So this is designed for that far edge deployment where it may be, something's mounted on a wall, something that's mounted in an outdoor enclosure. On the marketplace, we have a couple of outdoor enclosures for this unit that you can see are sealed and then heated and air conditioned as well to keep the, even though it has a wide temperature range, from the nebs, it does have also environmental control. So it's a sealed unit designed to be mounted on a pole or mounted on a wall or, on a ceiling or roof mounts as an outdoor, enclosure. But those are, optional things. Also, we have a seismic rated rack as one of the solutions. There was one of the white papers they were talking about earlier on the, for those of you who are here for the opening presentation by the group, one of the things that we've done is actually had a white paper on, deployment. And so what a full rack would look like along with, top of rack switches and the cables and kind of all those kind of things were included in a white paper for, and that would really be not a far edge deployment, but more for a, the next tier up where you have full rack, couple of racks worth of these, So it's kind of, your deployment model varies depending on, which area you want to go. And then, some people have wanted to put these in their data center. And we do have an OCP OpenRack version 2 system that's telco rated with nebs and all of that stuff that's available if you wanted to go for a data center full of, your traditional OCP type servers and then use these on a far edge, and then you can kind of choose where, at what point you make a break of I can have 2 racks of this versus 1 rack of the open ORV2 racks, Go ahead.
Yeah, speaking of deployment, could this be deployed at a cell tower, kind of like a distributed unit, like a DU?
Oh yeah. So that's one of the use cases for this chassis is a VDU, right? So this would be the VDU or VCU. It could be deployed on site. It could be deployed, as a front haul. So that Ethernet switch is actually a front haul gateway. So you could have, this acting as a VDU with multiple radio heads around it. He had the slide deck that showed the latency, so you need to be fairly close to the VDU from the radio, and then you can get a little further for the CU.
Do you have to add like FEC acceleration and timing cards and things like that in order to do that?
Yeah, well, so there are both models, and I think it depends on the vendor. Most folks will use some type of acceleration, usually either a look-aside acceleration for like FEC processing, those kind of things, or there's some inline processing that's coming, with like accelerated NIC functions, they call it, that does actually inline acceleration of functions. Because at that layer 1 processing that's done pre-processing before it's sent to the MIMO radios, for instance. There's a lot of work that needs to be done on those signals, and we continue to upgrade CPUs. The CPUs are getting more powerful. They're getting additional functions. Some of like the AVX functions and stuff from the Intel NICs are trying to bridge that gap so that you are able to use just the CPU, but most people use the accelerators. And Tommy talked about that a couple of times in his talk about, especially like AI, you're going to have some kind of GPU user, unit on there for doing that, or video transcoding. There's lots of different applications that have accelerator functions.
Yeah, I just would like to adding the information regarding for this gentleman's question.
Yep.
Or those kind of the timing card or need.
The timing, right?
So actually today there's the last session, last topic is gonna be about. So make sure stay until then.
Yeah, we have, all of the timing is very important, and we have both a project in OCP, that's the TAP project, which is all about timing. In these particular cases, for the cell site usage, those require the IEEE 1588, which is not orthogonal to the time protocol. That's still a PTP protocol, so it's still the 1588 timing. But yeah, that's very important. In the case of the front hall gateway switch, it provides actually a timing module that has an oven in it, so it'll give you a very precise time. It doesn't have the GNSS input, so it requires something else to give it a PPS signal and time of day, and then it can use that to synchronize with the antenna sites from the VDU. But yeah, timing is very important to the group, and while it's not specified in the specification as such, it's present in those in all of those things. And like I said, especially in that front hall gateway, which is going to be what's going to provide the timing outward to the radio sites. So, okay, are there any other questions before I think we have a break coming up. Oh, we ran out of time for the break. Cool, well, let's keep going then.